Hello students, our today's topic of discussion is gravitation. I am Harsh. Let's take a look into it. So from definition, gravitation is a universal force of attraction that acts between objects with mass. So notice here I underline three words. So gravitation is a universal force. What is universal force? That gravitational force will work across all the universe. It will work in my home. It will work on moon, sun, earth or any other distant planet or galaxies. And gravitation is a force of attraction. So unlike magnetism, if you are familiar with magnets, then magnets can attract or repel each other. But it is not the case with gravitation. It is only a force of attraction. It can never repel objects. And it acts between objects with mass. So if objects have mass, then gravitation force will work for them. So in high studies, you will see that there are some particles which have zero mass, for example, proton, for example, photon. Okay, but it is a case of higher studies. So here are two objects, two massive objects. So gravitational force will work between them. I represented that force with this yellow arrow, and I denoted that force with Fg, gravitational force. So let's take a look into the universal law of gravitation to understand better. It is also the mathematical model of gravitation. Yeah, so here is a familiar case. Sir Isaac Newton, the father of physics, he worked in the field of gravitation and gave us the universal law of gravitation in 1687. Okay, so I will explain this universal law of gravitation in two set of mathematical questions. The statement for the first law is that the gravitational force between the two objects who have masses m1 and m2 is directly proportional to the masses of those objects. So if gravitational force is Fg, then it is proportional to the mass of first object and as well as mass of second object. So here are two objects who have masses m1 and m2 and they are attracting with the force Fg. It is gravitational force. So if we increase the mass, notice here I use the darker shade of black for like much heavier mass. If we increase the mass, then the gravitational force is also increased. I denoted it with much wider arrow. Heavier the mass, higher the value of gravitational force. The second statement for the universal law of gravitation is that the gravitational force is inversely proportional to the distance between the square of the distance between these two objects. So if the distance between the objects is small r, then Fg is inversely proportional to the r square. Notice here two objects whose distance between them is small r and gravitational force is working between them. If we increase the distance between these two same objects to capital R, then the amount of the gravitational force will also reduce and it will reduce with the square of the distance between those values. So notice here I increase the distance and the gravitational force is also reduced. And yeah, we learned these three mathematical equations, and if we merge these equations, then we can say that gravitational force is proportional to the masses multiplication divided by distance square. And for removing this sign of proportionality, we have to introduce a new constant named capital G because that's how it's work. So what is this capital G? Capital G is basically universal gravitational constant. So let's see this universal gravitational constant value. So the value of this G is this value and the unit is Newton meter square per kg square. And it is universal. It is same across whole universe. Notice here you can say the value of G is very small. I mean 10 to the power minus 11 is very small number. So because of this small value, we are unable to feel the gravitational force in our daily life. So for example, here I have two markers. The force of attraction between they are also these markers are massive. These markers have mass, and there's also force of attraction working between these two markers. But I am unable to feel that force because that force is very less because these mass are not too much. If we take one marker and release it, then it will drop down to earth because in second case, one body is marker and second body is very much massive earth. So we can feel the gravitational force. Okay. Now there's a term named gravity, and yeah, there's a confusion between the folks that gravity and gravitation the same thing. So are the gravity and gravitation the same thing? The answer is no. Here is a scenario. Here are two bodies, and one body is like our familiar planet Earth, and other is some random body. Okay, so yeah, there are force of attraction working between them, and I can explain this scenario with two sentences. First, I can say that there is a force of attraction working between Earth and the body named as gravitational force. Okay, so here is the definition. You can say that it is the definition of gravitation. And I can also say that because of Earth's gravity, the ball is attracting towards the Earth. Okay, so notice here that gravity is not a force. It is an effect generated because of the gravitational force between the objects. Okay, so there is a gravitational force between the objects. Because of it, we can say that Earth's gravity attracting the object. So that is it. Thank you.